Almost every ancient civilization, master navigator, and modern astrophysicist started exactly the same way, staring out a bedroom window at the night sky, trying to make sense of what was up there. If you watch the sky long enough, you quickly notice a very distinct pattern. Over the course of a few weeks, the moon appears to completely change its physical shape. If you sketch those changes night after night, a clear cycle emerges. It begins with the invisible new moon, where the side facing Earth is entirely in shadow, progresses steadily into a bright, completely illuminated full moon, and then shrinks back down into darkness. Between those extremes, the moon passes through specific transitional shapes. We see a thin sliver called a crescent, then a half-illuminated circle known as a quarter, and finally a bulging, nearly complete circle called a gibbous phase. Looking up from the ground, it is easy to trust what our eyes are telling us. Is the moon physically shrinking and expanding in space? Or is the Earth casting a dark shadow over it every night? Our view from the backyard is actually an optical illusion. To understand the reality of what we are seeing, we have to leave the surface of the Earth and completely change our vantage point. When we pull back into outer space, the Earth, Moon, and Sun stop being flat lights in the sky and become three-dimensional objects locked in a massive spatial dance. This 3D model shows how the light actually works in a vacuum. The Moon is a solid sphere of rock. It never changes shape. And because the Sun sits at the center of the solar system, it is always illuminating exactly 50% of the Moon's surface. The phases we see have nothing to do with Earth's shadow. Instead, they are strictly caused by our viewing angle. As the Moon travels in its orbit around the Earth, we are simply seeing different fractions of that permanently sunlit half. When the Moon reaches a 90-degree angle to the Earth and Sun, we see half of its lit side and half of its dark side. If the right half is illuminated and growing, it is the first quarter phase. If the left half is illuminated and shrinking, it is the last quarter phase. The Moon takes roughly 29.5 days to complete one full orbit around our planet. Because that mechanical path is fixed, the visual illusion we see in the sky repeats in a reliable cycle. Now, the Earth casts a massive shadow into space, but it only touches the Moon during a specific rare alignment known as a lunar eclipse. This happens when the Earth passes directly between the Sun and a full moon. Sunlight bending through Earth's atmosphere often paints the Moon a deep rusty red. A total solar eclipse is the exact opposite alignment. During a new moon, the Moon passes directly in front of the Sun. This entirely blocks the solar disk and reveals the corona, the Sun's incredibly hot outermost atmosphere. If that celestial alignment is even slightly off-center, we experience a partial solar eclipse, where it simply looks like a giant bite has been taken out of the Sun. Because the Moon does not emit its own light, lunar eclipses are completely safe to look at with your naked eye. But looking directly at any stage of a solar eclipse without protection exposes your eyes to intense ultraviolet radiation, which can cause permanent blindness. To view a solar eclipse, you must use specialized solar filters, like approved eclipse glasses, or indirect methods, like projecting the Sun's image through a pinhole onto a piece of paper. Lunar phases are a daily trick of orbital perspective. Eclipses are rare moments of physical shadow play, events that demand our awe, and in the case of the Sun, our extreme caution. Thousands of years ago in ancient India, people were standing outside, watching these exact same 29.5-day cycles play out in the sky, without telescopes, satellites, or digital models. When the strict rhythm of the phases was suddenly interrupted by the sky going dark during a solar eclipse, early societies used storytelling to make sense of the terrifying anomaly. In Hindu mythology, eclipses were explained by the severed demon Rahu seeking revenge by temporarily swallowing the Sun and the Moon. But those same skywatchers kept tracking the patterns. Through generations of careful observation, figures like the 5th century mathematician Aryabhata began translating the movements of the sky into rigorous geometry. Classical Indian astronomical texts, like the Surya Siddhanta, meticulously documented the lunar phases and the exact angles of celestial bodies. By understanding that an eclipse was a physical shadow and not a monster, They developed mathematical formulas to predict exactly when the next eclipse would occur. Centuries of recorded observations and rigorous mathematics established the foundations of astronomy long before the invention of the telescope. Today, we use facilities like the Devastal Observatory in the Himalayas of Uttarakhand. With its 3.6-meter mirror, astronomers peer into galaxies and track exploding supernovas. We continue to chart the darkness and recognize the same cosmic patterns that our ancestors did, though we now use 3.6-meter mirrors to do it. Which brings us right back to the backyard. These orbital mechanics are visible from any window. Every observer with a notebook and the curiosity to look up is, in their own way, an astronomer.